Hello viewers, in today's session we are going to discuss an interesting problem from trigonometry. So here we are given secant theta minus cosecant theta is equal to 4 over 3, and we have to find the value of sine theta minus cosine theta, right? So this problem is going to be very conceptual, and here we are going to make use of the concept of quadratic equation, right? So let us see how we can find out the value of sine theta minus cosine theta when we are given this expression, right? So let us start or let us begin with this expression. So here secant theta minus cosecant theta is equal to 4 over 3. So let us replace secant theta by 1 over cosine theta, and cosec theta by 1 over sine theta. So we can now write 1 over cosine theta minus 1 over sine theta is equal to 4 over 3. So let us simplify. So here we have by cross multiplication and taking the LCM, here we have sine theta minus cos theta divided by cos theta and sine theta, and here we have 4 over 3. Let us again making use of cross multiplication, we can write 3 times sine theta minus cosine theta is equal to 4 times we can write sine theta and cos theta, right? So here this is an important expression. Now let us write this 4 as 2 times 2. So we can now write here 2 times 2 sine theta cos theta. Now here we can make use of the double angle formula for sine 2 theta, that is 2 sine theta cos theta. So we can now write here 2 times sine 2 theta for 2 sine theta cos theta. So now we have this expression, that is 3 times sine theta minus cosine theta is equal to 2 sine 2 theta. So now let us make use of this identity, that is a minus b whole square is given by a square plus b square minus 2ab. And let us replace a by sine theta and b by cosine theta. So we have sine theta minus cos theta square is equal to sine square theta plus cos square theta, and here we have minus 2ab, that is minus 2 sine theta cos theta. So now sine square theta plus cos square theta is equal to 1 due to the identity, and here we have 1 minus sine 2 theta. So 2 sine theta cos theta can be replaced by sine 2 theta, and sine square theta plus cos square theta is equal to 1. So we have sine theta minus cos theta square is equal to 1 minus sine 2 theta. So let us rearrange the terms. So we can now write sine 2 theta is equal to 1 minus sine theta minus cos theta square. So let us substitute the value of sine 2 theta in equation 2. So we have 3 times sine theta minus cos theta is equal to 2 times sine 2 theta. So sine 2 theta is 1 minus sine theta minus cos theta square, right? So now from this expression we can easily observe that here we have sine theta minus cos theta, here also we have sine theta minus cos theta. So for simplicity we can assume sine theta minus cos theta is equal to, say, x, right? So we can now have 3x replacing sine theta minus cos theta by x, and here we have 2 times 1 minus x square, sine theta minus cos theta square. So now this is a quadratic equation. So we can now write 3x is equal to 2 minus 2x square, and if we simplify it, then or rearranging the terms, we have 2x square plus 3x minus 2 is equal to 0. So this is a quadratic equation. Let us solve this quadratic equation by splitting the middle term. So we have simply 2x square, and here we have 2 times minus 2 is minus 4. So we have the two factors, that is 4x, and here we have minus x. So 4 minus 1 is 3, and 4 times minus 1 is minus 4, and 4 minus 1 is 3. So here we have minus 2 is equal to 0. So let us factorize. So taking 2x common, we have x plus 2. Then we have minus 1, x plus 2. And we have 2x minus 1, and x plus 2 is equal to 0. So the two roots of this quadratic equation may be given by these two equations, and here we have x is equal to half, here we have x is equal to minus 2, right? So now we have obtained two values of x, and we have already assumed that x is equal to sine theta minus cosine theta. So sine theta minus cos theta is equal to half, and then we have sine theta minus cos theta is equal to minus 2. So from these two expressions, we can see that the value of sine theta minus cos theta is either half or minus 2, right? But let us first verify the validity of these two expressions, right? So now we have just seen that sine theta minus cos theta square is equal to 1 minus sine 2 theta. So here let us write again this expression, and we have 1 minus sine 2 theta. So let us first see this one. So here we have sine theta minus cosine theta is equal to minus 2. So here we are actually verifying that whether the difference of sine theta and cosine theta is equal to minus 2 or not, right? So let us make use of this expression. Sine theta minus cos theta can be replaced by minus 2. So here we have minus 2 square is equal to 1 minus sine 2 theta. So this is 4, 1 minus sine 2 theta, and from here we can write sine 2 theta is equal to 1 minus 4, and that is sine 2 theta is equal to minus 3. So now from this expression, we can observe that sine 2 theta is equal to minus 3. But from trigonometry, we know that the minimum value of sine theta is minus 1, and the maximum value is 1. That is for some angle, say alpha, sine alpha must lie between minus 1 and 1, right? So here if we take alpha is equal to 2 theta, then sine alpha is equal to minus 3, and this is not possible because we have the range of sine alpha is from minus 1 to 1. It means the sine function has the range from minus 1 to 1. So sine alpha is equal to minus 3 is not possible. That is sine 2 theta cannot be equal to minus 3, right? So it implies that sine theta minus cosine theta cannot be equal to minus 2. So we have to discard this value, right? And will retain only this expression, that is will accept only this root of the quadratic equation, that is x is equal to half, and will discard this one. So let us verify this expression. So let us substitute the value of sine theta minus cos theta as half in this expression. So we have here half square, and this is 1 minus sine 2 theta, and this is 1 over 4, 1 minus sine 2 theta, and rearranging the terms, sine 2 theta is equal to 1 minus 1 over 4, that is 4 minus 1 over 4, that is 3 over 4. So we have sine 2 theta is equal to 3 over 4, and 3 over 4 is obviously it is greater than 0, but it is less than 1, right? So this equation is valid, that is sine 2 theta is equal to 3 by 4. Or in other words, we can say that there exists some value of theta for which sine 2 theta can be equal to 3 over 4, right? So from this discussion, we have seen that sine theta minus cosine theta cannot be equal to minus 2, but sine theta minus cosine theta can be equal to half, as we have verified this expression from this relation. So finally, we can claim that when secant theta minus cosec theta is equal to 4 over 3, then the value of sine theta minus cos theta is equal to half.